Alright, so we're going to do the same thing for tangent. Okay? So same thing, start off by writing my parent function for tangent with all of my transformations. So my center line is at y equals 2, which means it's been shifted up 2. My amplitude, or in this case my vertical stretch compression, is 2, so I've been vertically stretched. My period, that comes from b, using the equation p equals 2 pi over b, so it's 2 pi over 1/2, so 4 pi, which means it's been horizontally stretched, because normally it's 2 pi. And there is no shift, horizontal shift. Okay, so let's start off with graphing tangent. So tangent has an asymptote here, an asymptote here, 0, 1, -1, 0, +1, -1, 0. So here's the parent function. Very similar to cotangents. Okay? Now, center line is at 2. So here's my center line. Boom, 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 boom. Okay? My amplitude is 2. So up 2, down 2. Okay? Now, before we do anything, we're going to do my period change. So still going to start at 0 here. So my wave still starts here. But now it's going to be 4 pi long. So it means it's going to end here at 4 pi. Okay? So basically this box right here, again, if you're doing it the way I do it with the box method, basically that's where the meat of my trig function is going to end up. Now, I'm going to graph the major points of sine to help me with tangent. So sine zeros would be on the center line beginning at the end and in the middle of this box. And then the first one would be right in the middle here. That would be your maximum, and then minimum there. So this right here is what sine would look like if you were graphing it. And I'm going to use that to graph my tangent because they have the same zeros. So tangent 0 is going to end up here, there, and there, still on the center line. Where sine has its maximum, that's where your asymptotes are, maximum and minimum. And then since it's been horizontally stretched right in the middle here, that's where that 1 is, the middle here, -1, +1, -1. So this is the way tangent would look. And you can see how it mimics the sine wave.